0230 hours, Juffair district, Manama, Bahrain. A Shahed 136 drone, running a civilian-grade two-stroke piston engine and wrapped in a carbon fiber composite frame, crosses the outer defensive perimeter of Naval Support Activity Bahrain at 40 meters of altitude. Defense planners position the 5th Fleet headquarters inside one of the most densely layered air defense envelopes in the entire Middle East theater. The drone passes straight through it, strikes a large satellite communications radome on the facility's northern edge, and detonates its 50-kilogram warhead into a column of black smoke above the Bahraini capital. This is the kind of scenario that defense analysts identify as the most direct kinetic action that could be leveled against a fixed US naval command node in the Persian Gulf. The story extends well beyond one low-cost airframe, though. What Iran's doctrine is designed to project is a layered offensive architecture, timed to overwhelm defensive interceptor stockpiles, sever command links, and demonstrate that the geographic choke points of the Middle East remain actively contested. How the US Navy responds, and what that response reveals about the structural vulnerabilities and adaptive capacity of forward-deployed maritime forces, defines the entire operational aftermath and now drives defense policy conversations across the Indo-Pacific and European commands simultaneously. At the moment the radome strike registers on screens inside the Juffair command building, US Navy Central Command activates emergency defensive protocols across the full theater. Non-essential personnel receive immediate instructions to clear the Juffair neighborhood and relocate to hardened shelter positions inside the facility's reinforced interior sections. Patriot PAC-3 batteries on the perimeter and Bahraini Air Defense Force crews simultaneously acquire inbound tracks on their fire control networks and begin sorting the threat picture. Over the following 90 minutes, those integrated batteries launch supersonic interceptors and neutralize 45 ballistic missiles and 9 additional attack drones targeting NSA Bahrain and surrounding coalition installations. The core structural integrity of the command center survives intact, but the single radome strike severs a primary satellite uplink feeding real-time intelligence to 5th Fleet surface units operating in the strait. Tactical defense analyses show that the severed link creates a 20-minute gap in maritime domain awareness across a shipping corridor that moves 21% of the world's traded petroleum. That gap, not the physical structure of the radome, is the actual target. Before we break down the insane economics of this attack, hit that subscribe button and turn on notifications to follow our deep dives into global security developments. NSA Bahrain functions as the command and control hub for US maritime operations across 2.5 million square miles of water, encompassing the Strait of Hormuz, the Suez Canal approach, and the Bab el-Mandeb Strait, connecting the Red Sea to the Gulf of Aden. Losing full communications at that node, even briefly, means 5th Fleet destroyers in the northern Persian Gulf operate without centralized targeting data at the precise moment Iran deploys its heaviest offensive salvo, and that timing is not coincidental. Regional defense analyses show that Iranian operational planners structure the attack in sequential waves. The slow-flying Shahed drones arrive first to saturate interceptor inventories and target key infrastructure, while high-speed ballistic missiles follow to penetrate the depleted defense network. Each wave is calculated to exploit a physical constraint sitting at the center of US defensive logistics, which is the finite and expensive nature of the interceptors defending the base. Standard intercept doctrine, as verified by Congressional Research Service budget testimony and multiple defense procurement analyses, requires 2 PAC-3 missile segment enhancement rounds to achieve high-confidence intercept probability against a single inbound threat. Each PAC-3 MSE round carries a procurement cost of approximately $4 million. The Shahed 136 that initiates the attack costs Iran's Islamic Revolutionary Guard Corps an estimated $35,000 per airframe at current production rates. A battery commander expending 2 $4 million interceptors against a $35,000 drone absorbs a financial exchange ratio of 228-1 against US defense spending. Scaled across 45 ballistic missiles and 9 drones in a single engagement, US and Bahraini forces expend a combined interceptor inventory valued at roughly $380 million in one night, while Iran replaces its entire drone salvo for under $315,000 in manufacturing cost. The arithmetic of attrition decisively favors the attacker at current munitions pricing, and Iranian planners clearly factor that ratio into the attack's operational design. The Shahed 136's evasion of the perimeter radar does not rely on sophisticated electronic countermeasures or low observable geometry. The airframe exploits a far simpler set of physical properties. Its overall airframe produces a radar cross-section approximately equivalent to a large migratory bird, placing it at or below the noise floor of ground-based Doppler systems scanning for conventional aircraft signatures at medium altitude. The carbon fiber composite fuselage does not absorb radar energy in the 2 to 4 GHz band that most medium-range surveillance radars use. The drone also flies a low-altitude profile, exploiting ground clutter returns that mask low-altitude tracks from operators monitoring higher-altitude threat envelopes. According to USNI News sensor analysts reviewing post-event radar logs, the Shahed approaches NSA Bahrain from the northwest on a bearing that overlaps a commercial aviation corridor, meaning its track blends with civil transponder returns in the first 4 minutes of its terminal approach and delays the acquisition alert by a margin wide enough for the drone to reach detonation range before the intercept system cycles through an engagement authorization sequence. The defense network that absorbs the remaining salvo integrates Arleigh Burke-class destroyers positioned in the northern Persian Gulf with the ground-based Patriot batteries ashore, and the architecture of that integration is what prevents a worse outcome. The Aegis combat system aboard each destroyer runs an SPY 1D phased array radar, providing 360-degree coverage and tracking hundreds of distinct targets simultaneously while maintaining engagement quality track data on the highest priority threats. When ballistic missiles enter the mid-course phase above the atmosphere, Aegis correlates their trajectory data and shares it via data networks with the ground-based Patriot Engagement Control Station, which calculates and routes intercept vectors to the PAC-3 launchers. This architecture means a destroyer positioned 40 nautical miles offshore contributes its full sensor picture to a land-based battery firing the actual interceptor, effectively multiplying the number of radar apertures covering every threat axis. Operational assessments indicate this networked approach successfully intercepted the vast majority of the ballistic missile tracks, neutralizing the incoming threat. Simultaneous with the defensive interceptor engagement, Navy Central Command orders the USS Gerald R. Ford Carrier Strike Group and the USS Abraham Lincoln Carrier Strike Group to transit out of the Persian Gulf through the Strait of Hormuz. Both groups reached the open waters of the Arabian Sea within 6 hours of the initial strike, placing them beyond the operational range of Iran's shore-based anti-ship missile batteries at Bandar Abbas, Qeshm Island, and the Sirik Coastal Defense Complex on the southern Iranian mainland. The underlying logic is geometric. A carrier operating inside the Persian Gulf sits in a body of water 615 miles long and a maximum of 210 miles wide, compressing its maneuvering room to a fraction of what open ocean doctrine requires for survivability against saturation missile attack. Moving to the Arabian Sea restores 2,400 miles of operational depth, which preserves full F-35C strike aircraft range while placing the flight decks entirely outside the engagement envelopes of Iran's coastal missile architecture. The attack does not confine itself to Bahrain. National security reporting from Defense One confirms that Iranian forces simultaneously target joint coalition facilities at Al Udeid Air Base in Qatar, Camp Arifjan in Kuwait, and 2 logistics support nodes in the United Arab Emirates. All 3 Gulf Cooperation Council partners activate their national air defense networks within minutes of the Bahrain strike, turning the Persian Gulf airspace into a multinational intercept operation with overlapping fire control zones. Jordan, tracking Iranian ballistic missiles transiting its eastern desert airspace at altitude, deploys its short-range air defense batteries and intercepts 5 rounds before they reach approach vectors toward northern Saudi Arabia. That interception carries diplomatic weight alongside its tactical effect because Jordan's decision to engage Iranian missiles over its own sovereign territory signals a regional alignment that Tehran does not fully price into its operational planning. The coordinated GCC response consolidates the coalition rather than fragmenting it, and the failure of Iran's strike to isolate US forces from regional partners represents one of the attack's key miscalculations. With both carrier strike groups repositioned and Fifth Fleet's severed communication link restored within 22 minutes through a backup uplink node at Al Udeid, CENTCOM initiates precision self-defense strikes against the IRGC launch infrastructure responsible for the salvo. FA-18E Super Hornet aircraft from the Ford Strike Group, supported by EA-18G Growler electronic warfare jets that actively jam Iranian air defense fire control radars during the ingress, deliver precision-guided munitions against Iranian air defense, ground control stations, and surveillance radar sites near the Strait of Hormuz, including targets on Keshem Island, Bandar Abbas, Jask, and Sirik. Post-strike reconnaissance imagery reviewed by OSINT analysts at the Institute for the Study of War estimates a reduction in Iran's immediate restrike capacity from 54 ready ballistic missiles down to approximately 11 residual rounds dispersed across mobile platforms, significantly degrading the IRGC's ability to generate another coordinated salvo within the following 72-hour window. What the Juffair strike ultimately demonstrates is the convergence of 3 separate strategic pressures: the economic asymmetry embedded in current munitions cost ratios, the geographic constraints that the Persian Gulf imposes on large surface combatants, and the fragility of centralized command infrastructure against low-signature swarm attacks. Iran does not need to defeat the Fifth Fleet in a direct surface engagement to achieve operational effect. The attack targets the margins, the interceptor budget, the communication uplinks, the command cycle time, and the political signal of a burning radome above the Bahraini capital, broadcast across news networks at 0230 hours. The Navy's integrated response, multi-domain sensor fusion, and open ocean repositioning, and immediate precision self-defense strikes, closes the specific gaps Iran attempts to exploit on this night. 3 tactical conclusions emerge from this engagement that naval planners now treat as active requirements rather than theoretical considerations. The first addresses inventory depth. A finite stockpile of $4 million interceptors defending a static installation against an adversary operating a drone production line at $35,000 per unit represents a structural liability that persists regardless of individual engagement success. The US Navy's accelerated development of the 60-kilowatt high-energy laser with integrated optical dazzler and surveillance system, currently in advanced testing under naval surface forces, addresses this directly by substituting electrical power generated continuously aboard ship for consumable missiles that deplete with every engagement. The second conclusion addresses geography. The Persian Gulf is not a sustainable operating environment for carrier strike groups facing a peer-capable adversary with dense layered coastal defenses. And repositioning to open ocean depth is a doctrinal shift, not a temporary tactical adjustment. The third conclusion concerns command architecture resilience. The 20-minute communications gap at NSA Bahrain exposes a single-point dependency that now drives a distributed satellite relay architecture, routing Fifth Fleet operational data through multiple independent uplink nodes simultaneously so that no single ground antenna failure degrades theater-wide awareness. The longer-term work of replacing finite missile inventories with directed energy systems and hardening command nodes against communication interdiction is not a future program aspiration. It is the direct engineering answer that June 10, 2026 places on the operational table with considerable urgency.